So today we're going to go into truth tables in more detail. So last time I sort of introduced you to the concept of truth tables sort of on the fly. I used it to show how we define implication, right? So you might recall that I said that A implies B is logically equivalent, and we use that triple equal sign. I said that it was logically equivalent to not A or B. And I proceeded to show you by using a truth table. However, I never really just introduced truth tables on their own. And so that's what we're going to do now. Okay, so most of the um, lecture last time kind of blurred the line between semantics and syntax. So in this video, we're going to go over semantics in more detail, and hopefully that'll form a basis for how you should think of truth. And then later I'll introduce syntax. Okay, so what is semantics? Well, semantics, basically semantics, you can think of it as sort of the meaning of a sentence. So meaning of a sentence. Okay, and so this is where truth tables come in, right? So a sentence, or actually it's more properly called a proposition. So a proposition, right, is made up of atoms. Okay, and those atoms are those statements that cannot be broken up any further, right? So these are the statements that get assigned truth values. Okay, and then we make a truth we determine a truth value based on the atoms or the parts of the sentence, and we summarize this in a truth table. So the truth table is going to first have your atoms, and then after you go through all the possible values for the atoms, you build up the entire truth table. So the best way to introduce you to truth tables in general is to first do truth tables for and, or we already did implication, but we'll do it again, and negation, right? Okay, so the truth table for conjugation, right? Conjugation, that's just and, right? The conjunction. This is the following. So let's say you have P and you have Q, then we're going to make a little table. Ooh, that's a, okay, there we go. And this is going to be P and Q. And now what we're going to do is I'm going to assign some values here. Okay, so true and true. And then what else could P and Q be? Well, it could be true and false, right? And you can see that, it could be more stuff. So we're going to have to add a few extra rows, okay? Okay, so after you consider the possibility that P and Q are both true, then you say, well, maybe just Q is false and and P is true, and then you consider the case when P is true and Q is false, and finally you consider the case where both of them are false. Okay, so those are all of the possibilities. So in this case, P and Q are the atoms. They are the propositions whose truth value cannot be uh, any further broken down, right? So this is like when a child, keeps asking why, you have to stop somewhere, and we decide, hey, we're going to stop at P. You might be able to break it down further, but the point is that even if you could break down P further, the possible values it could be are either true or false, and so we're just going to assign those values. Okay, so I'm using red to denote inputs, and I'm going to use blue to denote outputs. And black is kind of the background, right? It's what we start off with. Okay, so the whole point of this is to determine what P and Q is, right? So this is going to be true just in case both parts are true, right? This is kind of like, if you do a testimony, they want you to give the truth, the whole truth, and nothing but the truth, right? And so if any part of it is false, then your whole testimony, well, the testimony as a whole cannot be said collectively to be true. And so that's how you can think of P and Q, right? So every part has to be true, otherwise it is false, right? So it's not like this one is more false than this one. It's just this is false, that's also false, this is false. Okay, so that's basically it for that. Over here, I'm going to show you disjunction. So disjunction, right? So there's conjugation, and then there's disjunction. This is or, and we're gonna do this little table, and we have our P, our Q, our P or Q, and then we do 4 rows. That's kind of a bad row. Let me do that again. Okay, great. So again, I'm going to go through these possibilities, right? True and true, true and false, false and true, false and false, right? And what could P or Q be? Okay, so if you think back to how I defined it, right, in the last video, I said it was true just in case at least one of them is true. So, or both. So if both are true, hey, that's true. Okay, P is true, therefore this is true. Q is true, so this is true. And both of these are false, so the whole thing is false, right? Okay, so like I said before, you can always come up with funny examples. P could be, 2 plus 2 is equal to 22, and Q could be, let's see. Okay, the road is wet, right? And if the road is wet, then P or Q is true, right? So the full statement, right? 2 plus 2 equals 22, or the road is wet, right? This whole thing is true, right? Because at least one of them is true, namely the road is wet, provided the road is wet. Now, a quick comment on this or statement. Um, if you just state something, right, um, uh, 2 plus 2 equals 22 or the road is wet, simply stating something doesn't make it true, right? So it's not like one of those has to be true or even both, but if neither of them is true, the whole thing is false, okay? Okay, so I'm not going to go over the truth table for implication because we did that in the last video, but just briefly I'll say it's only false, right? So A implies B is false if A is true and B is false. Okay, and then after, in just a little bit, I'm going to discuss some intuition for why that makes sense. Okay, but right now, I would like to go over the table for negation. Okay, so this one's going to be smaller, so we'll have P and we'll have not P. Okay, so our atom in this case is P, and our proposition, our sentence is not P. Okay, so P can only take on two values, right? So it could be either true or it could be false. And if T is true, sorry, if P is true, then not P is false. And if P is false, then not P is true. Okay, so this is negation, right? And I'll just sort of, as a bonus, I believe last time I said that P is logically equivalent to not P, right? So let's go ahead and show this, right? So this is, I guess you could say, an exercise. Okay, so let's go ahead and show that. So what's our atomic variable? Well, it's P, and what are we trying to find the value of? Not P, okay? But along the way, you try to break down something complicated into its simpler parts, right? And so one way you can think of this is that it's the same thing as not P, right? And so to know the value of this whole thing, you could just ignore this for a second and say, well, I'm just going to not this thing, right? So sort of intuitively, you can see that, hey, there's actually an intermediate step, right? I need to know what that is before I can determine the full value. Okay? So with that in mind, right, you need to make a bigger table, right? So not more rows, but more columns, right? So you're going to have P, you're going to have not P, our intermediate, and then the goal is not P. Okay? So just to summarize, you could say that this column is the uh, inputs, right? It's your atomic variable or atomic proposition. This is your full sentence, your proposition, and then sort of middle columns help you build up the more complicated thing. Now this one's pretty simple, but I'm showing this because, obviously later you're going to have far more complicated formulas, and you need that practice, right? So we have that there, and I'm going to say, okay, this could be true, this could be false, and from what we just did, right, what we just did, we saw that if you have this true, then this is going to be false, right, and this is going to be true, right? I'm going this way, right? I'm going along that way. And then the final answer is going to take the negation, right, of this, right, which is this column. Okay, so what's the negation of false? Well, there's only two values. There's only two truth values, true and false. So if you're not false, you're true. And if you're not true, you're false. And so because this column has the identical values as this column, and not just identical, right? These are also identical, these two, but they're not identical in the same manner, right? They have to line up, right? So, you know, every time we see a true here, we see a true here. Every time we see a false here, we see a false here, right? There could be more rows later on, more complicated sentences, but when anytime you have two propositions that are identical in every way, we say that they're logically equivalent. And remember, when things are logically equivalent, we use that that triple equal sign, and we can write this, right? Oh, and remember the hook, you can use a minus or a squiggly or a hook, right? They're all the same. Okay, so that's basically it. Oh, I did say that I wanted to briefly discuss, right? I want to briefly discuss A implies B, right? Okay, so why does it make sense? So this is a little philosophical uh, 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 aside, right? A little philosophical discussion. So why is it false only if A is true and B is false? Well, one way to think of it is that the only way it could be false is if you could falsify the statement, right? So it's kind of like, um, let's say that you apply for a job, or uh, you and let's say you apply for a job and you don't get it, right? Then you start to say things like, well, if I just had that job, right? Then it's all speculative, right? So just sort of to be friendly, you can say sure, right? Whatever you say, it's true, right? Why? Well, you don't have the job, so you can't falsify it, right? So certainly, if the antecedent, the thing on the left, is true, and the thing consequent, the thing on the right, consequent, not consequence, by the way, if you have true and false, right? Certainly that makes sense that the whole thing is false, right? So let's see why that makes sense. Well, suppose your instructor says, if you study, then you'll get a good grade, right? But let's say you do study, right? Let's say you study really hard, but you still get a bad grade, right? Then clearly that statement is false, right? Because you just falsified it, right? So if you study, check, I studied, then you get a good grade, but you don't get a good grade. Therefore, the whole statement is false. And so basically, the way I like to think about these if-then statements is that they only consider statements that can actually be falsified, right? Actually be falsified. So if you start speculating, we say, okay, yeah, go ahead, speculate all you will. Okay, so that's pretty much it for this lecture. In the next one, we're going to go over some more logic.